Welcome. This is 8.3 notes. We're going to go through page 6 and 7. We are on example 3, the one about the dollhouse. So the question says a dollhouse is 1/10 of the actual size. We should read the 1/10 and realize that is the scale factor. If a chair in the dollhouse is 2.75 centimeters tall, how tall is the actual chair that it models? So we are told that we have something that has been reduced in size, so that would be our image. This is our scale factor. So let's look at the information that we know. The scale factor is 1/10, which, if we turn into a decimal, is 0.1, and some of us may want to do that because it is easier to work with decimals with this formula, I believe. Our image size is 2.75 centimeters. So we use our formula. Object equals image over scale. We substitute in the values that we are told, 2.75 divided by 0.1. We see that the actual chair would be 27.5 centimeters. Moving on to example 4. Here we are told an example where Jess designs the logo shown for an environment club. She wants to enlarge the logo so that it can be applied to the front of a baseball cap. She initially thinks of using a scale factor of 300%. We're asked to draw the logo using the scale factor. So, as you see, there are measurements on there. There's the inner radius is 1 centimeter, and then the outer radius is 2 centimeters. So, what we first have to do is think about the scale factor. 300% is the same as 3/1, and so our scale factor is, in fact, 3. If we want to think about the inner radius, so that inner circle, which is initially 1 centimeter, 1 centimeter, which is the actual size of the logo that we have here, multiplied by the scale, which is 3, we will see that that will become 3 centimeters. Now the outer part, which is 2 centimeters, we use the same formula, actual multiplied by scale. Now we have 2 times 3, which is equal to 6 centimeters. We're asked also to use this information to draw the logo. So we should have a compass, and it would work out to something like this. This is how it looks like on your notes. First circle would basically come out to that letter E on B right there. And the second one, which is 6 centimeters, would come out right here in between the 3 and the 0 and 300%. And we're supposed to then use this information to answer the next question. Is this a good scale factor for a baseball cap? Well, if you look at a baseball cap, I would say no. It's too big. You try to put it on the front and it's going to almost take up the entire space. Perhaps 200% would be a better scale factor for this baseball cap. Okay, last example here. We are told here that we have a portrait that measures 50 centimeters by 35 centimeters. So reading that, if it's a portrait, it's an actual image. The larger side of reduction of it measures 20 centimeters. What is the scale factor of the reduction? So right there we're asked what is scale factor, so we know what formula we are going to use. We're going to use image over actual. The image is 20 centimeters. The actual size is 50 centimeters. When we calculate something like this, we got to always make sure that the units are the same, because we see that the centimeters would cancel out and we have a scale factor of 2/5 or 0.4. Moving on, we're supposed to use information from part A to answer the question in part B. The question in part B says, what is the length of the shorter side of the reduction? Well, the actual side of the shorter side is 35 centimeters. We calculated the scale factor, and we will use that. So remember, image equals scale, 0.4, times the object, which is 35. We see that the reduction is 14 centimeters. And these are the practice questions we will be working on next day in class.